Hey everyone, let's take a look at this factoring review. Ready? First one. So we are going to take a look at the first step in factoring the trinomial of x squared plus 7x plus 10 is 2. Now, when you look at a trinomial in this form, what we're supposed to do is we're supposed to look at the factor pairs of C and figure out which factor pair of C adds up to get 7. Is it 1 times 10? Is it 2 times 5? So that's the first step. Not list the factor pairs of 7 or take the square root of 7. It's list the factor pairs of 10 and taking the square root. That we haven't talked about that at all. Now, number 2, what kind of factor pair would you use for the trinomial? Well, if it's going to multiply to get positive 10 and add up to get 7, they would have to both be positive. And then number 3, the trinomial in factored form. Well, which one of these factor pairs would add up to 7? Is it 1 and 10? No, you're not going to get a 7 out of a 1 and a 10. Is it 2 and 5? Yes, it's positive 2, positive 5. And that's what my factored form would look like, x plus 2, x plus 5. Number 4, the first step to factor out the trinomial, 3x squared plus 15x plus 12 would be 2. Could I factor out a 3 from each one of these terms? Absolutely. They're all divisible by 3, so that looks like a great answer. But let's check the rest. Multiply 15 and 12? No, that's never a strategy for anything. List the factor pairs of 12? Well, I would do that if my a value was 1, but because my a value is 3 here, listing the factor pairs of 12 is not the right idea. And list the factor pairs of 15? That's never been a strategy. Number 5, can you factor out a GCF from this trinomial? 15x squared minus 10x plus 25. Is there a common factor between 15, 10, and 25? Absolutely, a 5. I could totally factor out a 5. But let's look at the next one. Can you factor out a GCF from this trinomial? 4x squared minus 7x plus 8. Do 4, 7, and 8 have a common factor? No. So we always want to check for a GCF, but you can't factor anything out there. Number 7, what would be the first step in factoring 2x squared plus 7x plus 3? So first of all, this is one of those trinomials where the a is not 1. So I'm not going to list the factor pairs of 7 ever. I never list the factor pairs of b. I'm not going to list the factor pairs of 3 here because that's when it's for a trinomial where a is 1. Would I multiply 7 times 3 together? No, that doesn't make any sense. But would I multiply 2 times 3? Absolutely. That's my a times my c. My AC value would be 6. And I want to list my factor pairs of 6 to get that 7. And so that's definitely what I want to do. Number 8, when factoring by grouping, the expression 10x squared minus 8x plus 10x minus 8 becomes, okay, so factor by grouping is where we factor the GCF out of the first 2 terms, and then we factor out the GCF of the second 2 terms. And when we do that correctly, we're going to see the twins. They're going to match up perfectly. So first one, GCF of 10x squared minus 8x would be a 2x. And if I factor a 2x out of both of those terms, I would be left with 5x minus 4. If I find the GCF of 10x minus 8, it's just a positive 2. And when I factor that, I'm left with 5x minus 4. How do I know I'm doing this correctly? It's because I see the twins. I see the twins. After factoring out my GCFs, if you have identical values inside those parentheses, it means you're doing it right. And so the first answer is actually my correct answer. Number 9, factor. Okay, so we learned that, listen, when we're factoring anything in any form, it has to be the greatest. If we don't factor out the greatest, it's not completely factored. So here, factor-wise, GCF of 4 and 12 is 4. If you say 2, it's a common factor, but it's not the greatest. So 4. Then I look at x squared and x. I can factor an x out of both of those terms. And if I have y to the third and y, I can factor out a y from both. Okay, so now that I factored out a 4xy, I'm doing the distributive property backwards. So I ask myself, 4xy times what gets me 4x squared y to the third? Well, I'm missing an x to get that x squared. And to get y to turn into y to the third, I need to multiply it by y to the second. 4x times what will get me negative 12xy? Well, that's just negative 3, and I don't need anything else because the xy is already there. And so in this case, that first answer is my factored form. Number 10, factoring this trinomial, x squared minus 10x plus 16. When the a value is 1, like what you see in front of the x squared is 1, those are the easiest trinomials to factor. It's just, hey, what factor pair of 16? 1 times 16, 2 times 8, 4 times 4. Can you get a negative 10 out of? Well, the only factor pair that you can get a negative 10 out of is a 2 and an 8. What kind of 2 and what kind of 8 will give you a negative 10? Both negative. And if they're both negative, they're going to multiply that to get that positive 16. So my factored form is x minus 2, x minus 8. And check it. Negative 2 and negative 8 add up to get negative 10. And when I multiply them, I get positive 16. Now, look, the answer choice was actually in an opposite order of what I had. Order doesn't matter. Okay, number 11. 2x squared minus 7x plus 3. Okay, so this is a trinomial where the a value is not 1, it's 2. And so I can't just list the factor pairs of 3. What I have to do first is I have to multiply 2 times 3. Okay, 2 times 3 is 6. And then I have to list my factor pairs of 6. 1 times 6, 2 times 3. And I have to ask myself, which one of those factor pairs can I get a negative 7 out of? Is it 1 and 6 or 2 and 3? Hopefully you're thinking, oh, it's 1 and 6. So then I bring down the first term, 2x squared, but we break apart the middle term using the factor pair that we chose. What kind of 1 and what kind of 6 get you negative 7? Both negative. So it's a negative 1x minus 6x. Now, that's like the opposite of what we've been so used to doing. We're so used to combining like terms, and here I'm asking you to take a term and break it apart. But you can agree with me, hey, negative 1x minus 6x is negative 7x. Like they're all equal to each other. And then you bring down the last term. Now, it does not matter what order I had written negative 1x and negative 6x. Okay, order does not matter there. The work will look a little different, but the final answer will be the same. So now, when I look at this, I factor by grouping. The GCF of these first two terms is x. I'm then left with 2x minus 1. The GCF of these next two terms is a negative 3. Remember, if the polynomial you're factoring starts with a negative, you need to factor out a negative. When I factor out a negative 3, I'm left with 2x minus 1. I know I'm doing it right because I see the twins. I put the GCFs in the first part of my factored answer, x minus 3 times one of the twins. And there you go, x minus 3, 2x minus 1. Okay, number 12. 3x squared minus 6x equals 0. Polynomial equation. Step 1. Set the equation equal to 0. Already done. It's already set equal to 0. Step 2. Factor. Does that look factored? No, that doesn't look factored at all, right? Because I don't see parentheses, so we need to factor. The GCF of these two terms is a 3x. If I factor out a 3x, I'm left with x minus 2. Step 3, set each factor equal to 0 and solve. So I'm going to set 3x equal to 0. I'm going to set x minus 2 equal to 0. When I set 3x equal to 0 and I divide both sides by 3, my first solution is 0. When I set x minus 2 equal to 0 and I add 2 on both sides, my second solution is positive 2. That's it. 0 and 2. Now, number 13 is very similar, but we'll have one little extra step to do. So this one says 8x squared equals negative 24x. Now, step 1, set the equation equal to 0. This is not equal to 0, so I have to do that. What I want to do also is I want to make sure that my polynomial is in standard form, and I have a nice positive leading coefficient. So I have to strategize here. Do I move 8x squared to the other side, or do I move negative 24x to the other side? Well, if I move 8x squared to the right, it'll become a negative 8x squared, and I don't want a negative leading coefficient. But I can set negative 24x to the left. Now, I don't want to put it in front because that won't be in standard form. I want to put it after the 8x squared. So this equation would become 8x squared. Now, if I send a negative 24x to the other side, it will become positive 24x equals 0. I then need to step 2, factor. I can factor out 8x out of both of those terms. And then step 3, set each factor equal to 0. So I set 8x equal to 0. I set x plus 3 equal to 0. And I'm just going to shortcut this, guys. Anytime you set a monomial equal to 0, it's 0. And then x plus 3 equals 0. What we should hopefully be realizing is that when it's those friendly little binomials where it's just x plus or x minus, the solution is the opposite sign. And there you go, -3 and 0. Number 14. Okay, a polynomial equation, but this one is a friendly trinomial. Step 1, set the equation equal to 0. Done. Step 2, factor. Okay, factor pairs of 12, 1 and 12, 2 and 6, 3 and 4. Which one of those factor pairs can you get a -11 out of? 1 and 12. Okay, so I know it's going to be 1. I know it's going to be 12. Which one needs to be positive and negative so that when I add them, I get -11. When I multiply them, I get -12. So one of them has to be negative. Hopefully you're thinking it is a -12 and a positive 1. And then last step, set each factor equal to 0. And again, what we should be noticing is every time we set a factor equal to 0, the solution is just the opposite sign when it's these nice little short binomials like x plus or x minus. Easy, easy. So -1, positive 12. Number 15. So x squared minus 5x equals -6. Step 1, set the equation equal to 0. Okay, so x squared minus 5x. If I send -6 to the other side, it would become positive 6 equals 0. Now, this could be a tricky trinomial. She could be tricky because when I look at this, factor pairs of 6 are 1 and 6, 2 and 3. And you can make an argument that you can get a -5 out of either one of those factor pairs, but signs matter. If I use 1 and 6, I would need a positive 1 and a -6. Now, a positive 1 and a -6 will add up to get -5, but what happens when you multiply those? Do you get positive 6? No. So 1 and -6 don't work. What about 2 and 3? What kind of 2 and 3 do you need to get a -5? Both negative. And what happens when you multiply both negatives? Do you get a positive? Yes. So sometimes we just have to be a little extra careful with our signs. But look, it's now in factored form. And then step 3, set each factor equal to 0. And I'm going to just grab my solution so quickly here because when it's x minus 2, it's positive 2. X minus 3, it's positive 3. That's it. Number 16, a very similar problem from the last. So this is just more good practice. X squared plus 9x equals 22. Step 1, set the equation equal to 0. Okay, so x squared plus 9x minus 22 equals 0. Step 2, factor. Factor pairs of 22 are 1 times 22, 2 times 11. Which one are you going to get a positive 9 out of? Hopefully you're thinking 2 and 11. So it would be a -2 and a positive 11. And then if I have x minus 2, my first solution is 2. X minus 11, my second solution is -11. All right, number 17. Number 17 is not the friendlier trinomial. It's the one where we have a little bit more work to do. So first, I see that I don't have an a value of 1. I should really check first. Can I factor out a GCF here? Do 5, 22, and 8 have anything in common? No. Okay. So next step, multiply a times c. 5 times 8 is 40. Okay, determine what factor pair of 40 can I get a -2 out of, -22 out of. 1 times 40? No. 2 times 20? Yeah. 4 times 10? No. 5 times 8? No. 2 times 20 is definitely the answer. So we bring down the first term. We break apart -22x using the 2 and the 20. So a -2x and a -20x. And then we bring down positive 8. We now do our factor by grouping. So first two terms, all I could factor out is an x. So I'm left with 5x minus 2. Second two terms, I can factor out a -4. Remember when the polynomial starts with a negative? We factor out a negative. And so if I factor out a -4, I'm left with 5x minus 2. I know I'm doing this right because I see the twins. I put the GCFs in the first part of my factored answer. times one of the twins. And now I'm completely factored, and I can set each factor equal to 0, and then I solve. If I set x minus 4 equal to 0, it's just 4. If I set 5x minus 2 equal to 0, think about the steps that you would do. You would add 2, and then you would divide by 5. So if I add 2, I have positive 2. Divide by 5, my solution is positive 2/5. And again, I just shorthanded what you can, of course, just write out all the work for. So positive 4, positive 2/5. Number 18, similar skill. So 4x squared plus 8x equals negative 3. Step 1, set the equation equal to 0. Okay, so 4x squared plus 8x plus 3 equals 0. Step 2, factor. Can I factor out a GCF first there? No. So in my factoring step, I need to do 4 times 3 is 12. Factor pairs of 12 are 1 times 12, 2 times 6, 3 times 4. Which one of those factor pairs am I going to get an 8 out of? 2 and 6, both positive. We bring down the first term, 4x squared. We break apart 8x using the 2 and 6, so plus 2x plus 6x. We bring down the plus 3. I do my factor by grouping. The GCF of the first two terms. GCF from the second two terms. I know I'm doing it right because I see the twins. First part of my factored answer is 2x plus 3 times one of the twins. And then step 3, set each factor equal to 0. If I set that equal to 0, I would subtract 3, divide by 2, and so my first solution is negative 3 over 2. Second one, if I set that equal to 0, I would subtract 1 and then divide by 2. So my second solution is negative 1/2. And again, if you're having a hard time following me on how I'm getting those solutions quicker, I'm just doing the math in my head. But again, you can just set them equal to 0, solve, and you're going to get those solutions. All right, number 19. Again, same skill. We're just going to keep practicing this. So 4x squared minus 13x plus 10 equals 0. Step 1, set the equation equal to 0. Done. Step 2, factor out a GCF. Is there? No. Okay, so now I just need to do my regular factoring. 4 times 10 is 40. We just talked about factor pairs of 40 before, so I'm going to go ahead and list them. And then I have to determine which one of these factor pairs could you get a negative 13 out of. Hopefully you see that it's 5 and 8. So again, for the third time, we bring down the first term. We break apart negative 13x using the 5 and 8, so a negative 5x, negative 8x. It does not matter what order I write those in, by the way. If you have them in a different order, the work will look different, but the final answer is the same. We then factor by grouping. GCF of these first two terms is just x. I'm left with 4x minus 5. GCF of these two terms is a negative 2 because I'm starting with a negative, and when I factor that out, it works out beautifully. I have my twins. I'm left with x minus 2 times 4x minus 5. What happens when you set x minus 2 equal to 0? You get 2. What happens when you set 4x minus 5 equal to 0? Well, I would add 5 on both sides and then divide by 4. So it's positive 5 over 4. Excellent. Last one. Last one. 6x squared minus 2x equals 28. Step 1, set the equation equal to 0. Okay, so 6x squared minus 2x minus 28 equals 0. Step 2, factor. Now, can you factor GCF out of this one? Yes, you can. You can factor a 2 out. And look what would happen if I factored out a 2 from all of these terms. I'm left with that little trinomial on the inside. And that's all I'm going to focus on. That 2 that I factored out is just going to hang out there. So ready? I'm going to multiply 3 times negative 14. It's negative 42. Let me just write that on the side here. What factor pair of negative 42 will get me a negative 1? Is it 1 times 42? No. 2 times 21. 3 times 14. Not 4, not 5. 6 times 7. You got it, 6 and 7. So ready, we bring down 3x squared. We break apart negative 1x using the 6 and 7. So I would need a positive 6x and a negative 7x to add up to negative 1. Bring down my negative 14 equals 0. Let's go ahead and erase that so I have space. Again, I bring down my 2 that I factored out. I now factor out the GCF. So GCF of these first two terms is 3x. I'm left with x plus 2. GCF of these second two terms is a negative 7. I'm left with x plus 2. Final factored form, ready, is the 2's on the outside. Then I have my GCFs of 3x minus 7. And then I have my last part of x plus 2. And that little GCF of 2 that we factored out from the beginning just stayed on the outside there. You can't set 2 equal to 0. That just doesn't make any sense. So there's no solution from that part. But if I set 3x minus 7 equal to 0, I get 7 over 3. And if I set x plus 2 equal to 0, I get negative 2. That's it. Those are my solutions. I hope that you were successful during this review. Good luck on your quiz.